Good morning, all. Today's topic is algorithms. Actually, what is an algorithm? It's an algorithm is a finite set of precise instructions for performing a computation or for solving a problem. Mean to say, we have to make a concise instructions will be given to the specific problem we have to decide it. It is just like a program, and it is one type of algorithm, just like, and all the programs are called algorithm, and not all algorithms are programmed. Why? Because in the program we have make the sequence of the operation we can perform, but in the case of the all algorithm we make the sequence of the steps we can perform. We according to that we cannot perform the program. That's why not all algorithms are the programs. Directions, for examples, we have taken the direction to the somebody house is an algorithm, and again the a recipe of cooking a cake is an algorithm. In that cases, we have make the sequence of the steps we have given over there. Okay? The steps to compute the cosine of 90-degree is an also the part of the algorithm. When we are explaining the each terms to compute the cosines of the 90-degree. Some algorithms are harder than other, and some algorithms are easy. For example, the finding the largest value in a list is just like the algorithm that we counted as the easy one. And we calculate the finding a specific value in a list, that is also the count as the easy algorithm. But sometimes the algorithms are the bit harder. Uh, for example, sorting a list uh, is the bit harder case of the algorithm, and some algorithms are very hard. For example, the finding the shortest path between the Baddi and Chandigarh, because the path we have considered in the case of the Baddi and Chandigarh may be different, and we already apply the multiple algorithm can be taken. Some algorithms are essentially impossible. For example, the factoring the large composite numbers we will count it as the impossible cases. In this, now we are taking the examples of some of the algorithm to calculate. These are the algorithm we have taken. The maximum element, for example, given a list, how do we find the maximum element in the list? In that cases, we considered to express the algorithm, we will use the pseudocode. And so what is the pseudocode? Pseudocode is a kind like a programming language, but not a really. We just explain the terms how we can incorporate in the case of the programming. These are some conventions we are using the algorithm pseudocode conventions. Uh, we have given normally these following conventions can be considered. The first one, comments begin with the two forward slash and continue until the end of the line. We mean to say some of the comments we want to include in the case of the pseudocode, they must be use the two forward slashes. Second, the collection of the simple statements are indicated with the matching braces. Whatever the statement we can be included, they must be included within the matching braces. Third, the statement delimited by the semicolon. Why? Because each statement we have to analyze that a statement must be exit. That's case, the statement must be delimited by semicolon. Fourth, the assignment of values to variable is done using the assignment statement. These are the normal statement we have to consider. There's a variable equal to expression. They write like that. Uh, Next, use two volume value, that is true and false, for the logical operator, and or not any relational operator they can be considered. He takes only the value we have considered, that's called true and false. That's why the normal convention we have taken in the case of the algorithm, the true and false will be there. The elements of multidimensional array are accessed using the large braces, that is called and. For example, if we included the ijth element of the array is denoted as aij, they can be considered as the array element. Somehow we consider the various statement, that is called the looping statement, employed can be done. Likewise, the for, while, repeat until the statement can be executed. the syntax will be the same as the considered with the while conditions. Do the statement one up to the statement one can be executed. Meanwhile, just like that, for variable, they can be considered as value one to the value n, and statement one up to the statement one can be executed. Likewise, the repeat until can be considered. The only difference between while and the repeat until, the condition can be initialized in the case of the while, but in the case of the repeat until, the condition will be executed in the case of exit condition will be there. Just same, the condition statement we can use if conditions, then a statement, and the read write used for the input and output value. Use pseudocode algorithm just like algorithm name and parameter list can be analyzed the what type of the procedures we can use in the case of the algorithm. Now considering the algorithm of the maximum element, algorithm for finding the maximum element in the list. These are the normal pseudocode we considered. The procedure maximum, the element we have considered that A1, A2 up to AN, and what type of element we are considering, that is the integers value. That's why we include in the case of the pseudocode the number of elements, and the data types we are considering, that is called integers. And the task we have to assign the algorithm to find the maximum. That's why we initialize the new variable that is called max equal to A1, and according to that we are comparing each element to consider which element are the maximum. That's why we one of the conditional pseudocode or conventions can be used for I equal to 2 to the n, and comparing the case if m max is less than ai, then max equal to ai according to the LHA. These are the pseudocode conventions you can implement according to the program we have to use. The maximum max is the largest element in the case of the algorithm we have. Again, we procedure the max to consider how the calculated the this value and number of value we have considered, and according to that the how we are calculated the maximum element. In this way, we consider the element 4, 1, 7, 0, 5, 2, 9, 3, 6, and 8. These are the elements of and number of elements we have considered. Meanwhile, we make the allocation according to the index 1, that A1 index to 4, A2 as a 1, A3 7, A4 0, A5 5, and A6 2, A7 9, A8 3, and A9 6, and A10 8. We have allotted the array elements up to A1 to A10, the element we have considered. Second statement, we have executed the maximum equal to a1, whatever the element we are starting the element that we considered as the maximum one. That's why max equal to a1. That is a1 equal to 4. In that cases, we allot the value that is called max. This is the case. The maximum value will be the 4, and after that we consider the condition and statement for I equal to 2 to n. Now we get the value that is called I, that is denoted over there, that is called I equal to 2. Meanwhile, we have computed the value up to the n. Thus, assigned the value 2 to the index value that is called A2. If the value checked and checked, again checked, 1 is the obviously the less than 4, whatever the value we have assigned. Next, third we have taken I equal to 3, the 7. Now in that cases the value we are comparing max is less than equal to ai, and the ai value is a3. The 7 will be reflected the maximum element. The condition is true, where max is the whatever the value we have assigned earlier, that's max is less than the current value that is called a3, that's we taken the max equal to ai and updated the value, that's the updated value, that's the max is considered as the 7 one. Now again continue the loop that is called a4. The value will be the again the less than of the maximum value of 7. Next 5, the suffix value of a5, that is called again the less value of the maximum. Next, a6 loop continue till the last element we have executed. A2, again 2 is less than 7, consider next point. Next, a7 is the value 9, again now 9 is the higher than 7, that's why we update the maximum variable, that is called 7. Okay, I mean, likewise we are considering the different value of up to a1 to a10, 3, 6, likewise last one, that is called 8. And the updated, the we have considered all the 10 value, and after completing the index value that I to 10, we find that the maximum value is 9. Max equal to ai, the max equal to 9, this case maximum element and the case of the running time. And how long does it this takes? If the list has n elements, worst case scenario that it takes n steps, because if the elements we like exist in the n number of elements, that's why the n steps will be executed. Okay, so the here are steps we considering a single step through the list. The properties, what are the various properties we are considering? The algorithm. The algorithm generally share a set of properties. The first, the input, what are the algorithm takes in as input. Second, the output, whatever the algorithm produces as the output. And the third one, definiteness. The steps are defined precisely. Why? Because if we make the algorithm and the terms we have used in the case of the different steps are not clear, they cannot defined precisely, the error will be generated accordingly. The correctness should produce the correct output because we analyze the algorithm according to that. Finiteness, the steps required should be finite. We are designing the steps and we know what the algorithm are working. That's why the proper result will be considered. That's the steps required should be finite. Effectiveness, each steps must be able to be performed in a finite amount of time because the algorithm must be efficient one. Each steps will be more effective. Generality, the algorithm should be applicable to all the problem of a similar form. In this way, we are making the algorithm. Now, for the first one, the searching the algorithm, we are taking the list of the element, find a specific element in the list. We will see two types, uh, the linear search and sequential search, for example. And the binary search, we have taken. We are now considering the linear search. Given a list, find a specific element in the list. List does not have to be sorted. Okay, these are the pseudocode we are considering the case of the linear search. Procedure linear search, we consider the element, whatever the element we are considering, that is integer value, that's a1 to an, and initialize the value I1 equal to 1, and while we repeat the process till the n number, because we are considering an element and an x not equal to ai. Steps, each steps will be forwarded by that statement we are using the pseudocode, that's called I equal to I plus 1. Repeat the process, and we will also find the element. If we are finding the element, the location will be the I, that is the ith locations we are considering. Location is the subscript of the term that equals x or it is 0, mean to say that the x we are searching is not over there. Now, algorithm 2, linear search take 1, procedure linear search. According to that, last examples we have considering. Uh, Again, the value will be the x equal to 4170529367, and we are searching the value that is called 3. Okay, start the pseudocode of the linear search algorithm. Starting the process, make the array, the elements of a1 to a10. I1 equal to 4, comparing 1 to 4, this I equal to 1 plus 1. Next value will be analyzed, the I equal to 2. Again I not matches with the I2 not matches with the value we have searching, that is called x equal to 3. Next the value a3, same, the increasing the index value, that 7 not matches with the value we have x, 0, 5 is not matching with the 3. Next 2 not matches with the value 3. Next 9, we continuously be making the uh, updates the value of I1 because we are not getting the whatever the searching the value we have. Okay. This is the case, 9 3 6. The we now we find the value that is called x equal to 3. If we find that value I, what is the value of I, that is called n, and the we that value of n equal to the location, the location at that time, that is called 8, that is the location. This is the case, the value we have considering that is 8, that's why the location is 8. Okay, in this way value we are making the linear says that we have taken the value of 11. Again the value we are searching a1 to 18, but in that cases we are considering the that value that is not find, the location will be considered as the 0. That's why we are just considering the examples to show whether the element doesn't exist in the set of the array and what the result will be result accordingly. This is the case, we are considering first value, second value, third value, fourth value, fifth value, sixth value, seventh value, eighth value, ninth value, and tenth value. Now we consider all the value. We have I equal to 10. The value we have considered, that case the location will be I, and that location will be the 0 because the value doesn't exist within the set of the array. Okay. The linear search running time and how long does this takes. If the list has an element, the worst case the scenario it takes n. I mean to say, if number of n steps, n number elements exist and the element doesn't exist, that mean to say we have to traverse all the numbers of element and they exist. That's why the worst case with the n steps will be taken. In the here is a steps is considered a single step through the. Now we are considering the algorithm that's called binary search. In that cases, we are given a list and find a specific element in the list. List must be sorted each time it iterates through the, because the list in half. Why? Because the binary search mean to say we are dividing the element into two parts, half part and next half part. In this way we are making the pseudocode. These are the pseudocode we are considering. Procedure binary search, the n number of value we have considering, what is the value of I equal to left hand point, considering the left hand point of the search interval, that's why I is the left hand point and j is the right hand point of the search interval to cut the list in the first half or second half. And considering while I less than is j, because we have to consider the element always be in the higher one. The next we start the begin the location of the substituent that equals to x and 0 if x is not found. The same as the linear search. If the location doesn't found, that list that is 0 will be the. Okay. Now taking the examples, the value we are going to the search in the case of the binary search, and the procedure we are calling the binary search pseudocode we have already given in the last slide, that there is implemented over there, and take the elements. These are the 10 elements we are considering, and we are going to compare the binary search according to that. Suffix array can be exist a1 up to a10. This way I1 I equal to 1, we the left part of the value that's called a1 equal to 1 this case, and j equal to n. This is the what is the right hand part of the, that's called 10. Because we are the binary search, we are making the divisions of the first hand of the second hand. The first end point we have taken and the second end point will be taken according to it. Now loop continue while I less than j, because the last element must be the minimum according to the first element. Okay. That's the I. Now we, whenever we start the value of the comparing, we have to divide the list of the element in the two half. That's why m is the value that is I plus j divided by 2. Okay, and this case 1 plus 10 11 divided by 2, that is called 11 by 5, nearly 5 we have taken. The a5 is the value 10. This case again x greater than an, the element we have, the middle element we have considering, and I equal to m plus 1. According to setting the value of this one, the value I equal to 6, 12, 14. Next middle we have taken because the binary search tree, first half, first half, first half, according to it, we have set. Next 16. Now we have considered the next value, the 16. Next middle point, next 6. The value will be the middle one. This. Okay. This is the case. The location we have taken, we find the value that is for 14, and the location with the 7. And in that cases, we haven't considered the all set of the element by searching, because we have taken the midpoint, and that midpoint we are searching the value that is the higher than of that value, middle value. Only that value can be searching. In that case, we are not considering the all of the value. Again, we are searching the 15 value. We are divided the value first half and second half. Now we are considering the first and half and the middle point. The middle point is 10. It means to obvious to say the element will be searched or will be in the second half. Okay. Now again the second half, the first element will be considered as 6 and 10, because the half point is the less than of the 10. Obviously we are searching the value that is called 15. So we will search that value in the case of the second. Okay. We will repeat the process till the value we have searched, and we find the value. We didn't find the value that is called 15 because they doesn't exist over there. That's the case. In this way, the alternative view to binary search. And how we can calculate the running time? So normally we case the worst cases if the list has the 8 elements and it takes the 3 steps. Okay. If the list has 16 elements, it has takes 4 steps. If the list has 64 elements, it takes 6 steps. Mean to me, and by first element, second element divided by 2. That's why if the list of has n elements, the value we are taking as the log with the base 2. Okay, the 8 comes the 3 steps according to the log of the base 2 to the power 3, 2 to the power 3, log 2 to the power 3. When the power comes forward, the value will be 3, and the base of the value of 2 by 2 is same, that the value will be the 1. That's why the log n is the worst case in the case of the binary search. Accordingly, we are making the algorithm solve in the case of the linear search algorithm and binary search algorithm. Okay, so we can consider the various algorithm, but now we are just going to understand what are actually the algorithm, and how the algorithm works, and how we can calculate the algorithm in the case of the linear search and binary search algorithm. Okay, today's lectures over. If we will come with the next lectures on the next slides. Thank you.